Hi, in this video we will go through AWS Virtual Private Cloud basics. We will first go through the definition of Virtual Private Cloud. We will take a look at the AWS Virtual Private Cloud architecture. We will examine the VPC components. And finally, we will understand what is a CIDR block and how to calculate the CIDR range for the VPC and subnet. Alright, let's start. Before we go into the definition of AWS Virtual Private Cloud, first, we would like to take a look at a traditional data center design. Now here in this example, we have this website, ProCloud Certify, which this enterprise owns. And the purpose of this website is to provide educational videos for cloud computing. Now, the enterprise objective is to build an application that is fault tolerant, highly available, and scalable. Now, to achieve these three objectives of fault tolerant, highly available, and scalable, the traditional data center would employ a three-tier architecture design. Users who are accessing the website, either via laptop or mobile devices, would enter the requests, and the requests would pass through the internet gateway, and from the internet gateway to the load balancer. And from the load balancer, it will be assigned to any one of these virtual machines. The initial request would first go to the presentation tier. The web server will be built to handle requests coming from the front end and process those requests and then return the output to be displayed over the internet on their devices. The second tier would be the application tier, and it would take care of all the business logic. And the final tier would be the database tier, where all the users' data would be stored and managed. Now, the problem with the traditional data center design is all these servers need to be planned and needs to be purchased by the enterprise. And because there's an initial capital expenditure requirement and there's a fixed number of servers that have been purchased to cater to a certain planned capacity, this as a result does not allow the enterprise to build an application that is fault tolerant, highly available, and scalable. For example, in case there would be any issues, a technical issue that would cause any of these servers to go down, in such a case the application would encounter issues and it would no longer be fault tolerant or highly available. Also, because a fixed number of servers have been purchased to cater to a certain expected demand, in case this website turns out to be highly popular and the number of users generating requests to access this website and the videos are far more than what was originally planned for, then there's no way to immediately acquire more machines that could handle the additional requests. And our objective of designing a scalable application would also not be achieved. So that is why most enterprises now are planning to move to the cloud instead of employing a traditional data center. So in our next video, we will understand how the AWS cloud helps to create an application that is fault tolerant, highly available, and scalable. So the definition of virtual private cloud. Amazon Virtual Private Cloud, or more commonly known as Amazon or AWS VPC, lets you provision a logically isolated section of the AWS cloud where you can launch AWS resources in a virtual network that you define. This virtual network closely resembles a traditional network that you would operate in your own data center with the benefits of using scalable infrastructure of AWS. So as our previous example here, a traditional network that we were operating in our own data center, because we would encounter issues and our objective was to build an application that is fault tolerant, highly available, and scalable, and we would be limited with the infrastructure from our traditional data center, we will use the scalable infrastructure of AWS to build this virtual network. In this diagram, you can see the difference between designing our application in the AWS Virtual Private Cloud versus designing the same three-tier application within our traditional data center. To design our three-tier application within the AWS Virtual Private Cloud, we first start off with the AWS region. Depending upon the kind of application that we have, we would select the region that supports the features and services that meets the requirements of application. Also, we would select the region that is closest to our users in order to ensure low latency. Once we've selected our region, we then build our isolated network, which is the virtual private cloud. We would leverage the availability zones within the virtual private cloud to then create a highly available application. This ensures that in case this availability zone, which is a traditional data center, if one of the availability zones were to go down, we would still have another availability zone to handle the requests and be able to ensure that our users have a fault tolerant and a highly available application at all times. In the traditional data center, we could always purchase more machines. However, all these machines would be in a single data center. So if this data center were to go down, then this application would no longer be highly available or fault tolerant. The AWS Virtual Private Cloud not only helps us to build a highly available application, but also helps us to build a much more secure application due to the various security features contained within the virtual private cloud. So when our users access our website and log in to view the educational videos, the requests from the users come via the internet gateway. They go to the Elastic Load Balancer. The load balancer then would allocate and apportion the requests across availability zones. The request would also go via a route table, which would determine what network traffic goes in or out. This would further be filtered through the network access control list. The network access control list acts as a firewall for our subnets. Subnets are smaller subnetworks within the VPC. Subnets are always tied one-to-one with a single availability zone. Unlike the virtual private cloud, which spans multiple availability zones, the subnets are tied one-to-one with a single availability zone. So our data would come from the internet gateway via the load balancer, via the route table, via the security controls of the network access control list, which is the firewall for the subnet. And further, before coming to the machine, the EC2 instance itself, they would go to the security group. The security group acts as another firewall for the instance itself. So this way, any traffic coming in or out goes through multiple filters and checks, and we leverage the AWS infrastructure to quickly configure and deploy these resources, whereas compared to a traditional data center where we would have to build these controls and security controls within the traditional data center ourselves and at our own expense. We can also further enhance security by having more than one VPC in our AWS account. Now, in our three-tier application, we have a web server which we want to be internet facing. We have an app server which we may decide that it should not be publicly available via the internet, and we control that via the controls of the subnet and the route table. So the route table ensures that only the subnets containing the web servers have access to the internet, but the app server does not have any access to the internet. Now, to further ensure security and to prevent any errors created by a developer, if we want our database to be completely isolated, we can put it into another VPC with a different CIDR range. So the VPC for our web server and app server could be a different IP range, and our database server could be in a different IP range within a different virtual private cloud. This ensures that any requests coming from the app server to the database server can only happen via VPC peering, and there is no way for information from the database to be directly accessible via the internet. So a well-designed application architecture would leverage all these services coming from AWS Cloud. We would use availability zones to ensure that our application is highly available, and in case entire data center were to go down, we would still be able to provide our services via another availability zone. We would leverage the subnets to add another layer of isolation. This ensures that only certain subnets would be accessible to the internet, and the route table would ensure that certain subnets would not be accessible via the internet. Also, we could have more than one virtual private cloud, and we could keep our database further isolated in a separate VPC to ensure further controls from any unauthorized access from the internet. So this shows how application architecture should be designed within AWS and within a VPC. In our next section, we will go through all these various components such as internet gateway, route table, network access control list, subnets, and security groups in a bit more detail. In this section, we will go over virtual private cloud components. The first component in a VPC is the internet gateway. The internet gateway is a mix of hardware and software that connects the instances in our VPC with the internet. The second component of a virtual private cloud is the route table. The route table has the set of rules that determine how the network traffic is directed. Now, we could decide in our application architecture design that subnet 1 should be a public subnet, whereas subnet 2 should be a private subnet. Now, what is a public subnet? Public subnet means that the network traffic that is allowed both in and out of the subnet is both the local network traffic of the virtual private cloud. So data from subnet 1 could go to subnet 2, and also network traffic can move in and out via the internet gateway. Whereas subnet 2 is a private subnet, and the only network traffic that is allowed in or out of the subnet is the local traffic of the virtual private cloud. So with route tables, we're able to add another level of security to control the kind of network traffic that goes in and out of our subnets within the virtual private cloud. The third component of the VPC are the subnets. Now the subnets are basically a division of the full range of the IP addresses contained in the CIDR block of the VPC. We take the CIDR IP address range of the VPC and divide it into smaller parts which are called subnets or subnetworks. Subnets are tied one-to-one with availability zones. So unlike the VPC, which spans across availability zones, the subnets are tied one-to-one with the respective availability zone. This ensures high availability because if the machines within one availability zone or one data center were to go down, the other machines in the other availability zone would still be available to manage the requests coming from our users. Also, the instances are launched from the subnet, not from the VPC. The fourth component is the network access control list, or also known as NACLs. NACLs are the firewall for the subnet. They act as an extra layer of security and help determine what network traffic goes in or out of the subnet. The final component of the virtual private cloud is a security group. Security group are the firewall for the instances itself. So unlike the NACLs, which are the firewall for the subnet as a whole, the security group act as a firewall for the instance and act as an additional layer of security to determine what network traffic can be accessed via the EC2 instance. So the internet gateway, route tables, subnets, NACLs, security group, these form the components of a virtual private cloud. When you create a virtual private cloud, you must specify a range of IPv4 addresses for the VPC in the form of a classless inter-domain routing block, also known as a CIDR block. To understand what this means, we need to first understand what is IPv4 range. IPv4 uses 32-bit addresses for Ethernet communication. IPv4 is made up of 4 octets of 8 bits each. So if you see over here, these 8 bits, 2 to the power 8, which equals to 256 IP addresses. So each octet could range from 0 to 255 IP addresses. So as a whole, IPv4 is made up of 4 octets, and these 4 octets could range from all the way from 0.0.0.0 to 255, 255, 255, 255. Now before classless inter-domain routing came about, IPv4 uses class-based network addressing. So it was classes that are used to divide the range of IP addresses. So let me show you how. So for example, class A. In class A, the first octet of 8 bits was reserved for the network. The remaining 24 bits, 8 plus 8 plus 8, was available for hosts or IP addresses. So 2 to the power 24, which equals to approximately 16.7 million IP addresses, is available in class A. In class B, then 16 bits are reserved for the network. So the number of hosts or IP addresses available is 8 plus 8, which is 16. So 2 to the power 16, which is approximately 65,536 IP addresses. For class C, 24 bits are reserved for the network. 8 plus 8 plus 8, that's 24. And only 8 bits are available for hosts. So 2 to the power 8, which equals to 256 IP addresses. So now let's go a bit more into detail what is CIDR block and how it's used in determining the number of total IP addresses for the virtual private cloud. So CIDR means classless inter-domain routing, and what it does is it replaces the older system based on classes. With CIDR, we use the / prefix to denote the number of bits reserved for the network. So if this is our IP address, okay, what we do is to denote what the number of IP addresses in our virtual private cloud, 10.5.0.0/16. So what this means is, now the first 2 octets are reserved for the network, and the remaining 2 octets of 8 bit each is now available as IP addresses or hosts. So 32 minus 16, which is 16, or 2 to the power 16, represents the 65,536 hosts. So same like class B, okay, we now denote, instead of mentioning class B, we use CIDR block range to state that our virtual private cloud would have 10.5.0.0/16 65,536 IP addresses. Then when we want to specify our subnets, we will then use 10.5.0.0/prefix 24. So 24 means the first 3 octets, which is 8 plus 8 plus 8, 24 bits are reserved for the network, and we have only 8 bits for hosts. So 2 to the power 32 minus 24, so 2 to the power 8, which is 256. So within the subnet, I only have 256 IP addresses available. So this will be used to show how we use the CIDR block to divide our virtual private cloud into subnets. We first specify that so in this example over here, in this diagram over here, I'm using 2 virtual private clouds. This one has an IP address prefix of 10.5.0.0/16, and this one has 10.6.0.0/16. So in virtual private cloud, let's call this VPC A. the total number of IP addresses, how does it come about? So we divide the first VPC 10.5.0 by 16. So that is basically 256 subnets, and each subnet will have 256 hosts. So 256 into 256. So there are each VPC will have a total of 65,536 IP addresses. Okay, so we give each subnet a CIDR range of 10.5.0.0/24. So in the previous example, 32 minus 24 is 8. So because 24 bits are reserved for the network, so we have only 8 bits available. So we have 2 to the power 8, 256 hosts. Now if you see over here, this is our VPC range 10.5.0.0/16. This means 65,536 hosts. The number of subnets we can have in this VPC will be ranging from 10.5.0, and this is the first subnet. Then 10.5.1.024, this is the second subnet. The third subnet would be 10.5.2.0/24, and the last subnet in this VPC would be subnet 255, 10.5.255.0, and each subnet has 256 IP addresses. So subnet 1 would start with 10.5.0.0 followed by 1, 2 all the way to 255. So subnet 1 has 256 IP addresses, subnet 2 has 256 IP addresses, all the way to the 255th subnet, which also has 256 IP addresses. So 256 subnets multiplied by each subnet having 255 IP addresses, 65,536 total hosts or IP addresses available. And similarly, the VPC 2 would also be divided in a similar fashion. So I use the prefix 16 to denote that this should have 65,536 hosts. So it's divided into all the way up to 256 subnets, starting from 1, 2, 3, and the 255th. So 1, 2, 3, all the way to the 256th, which is 255, because it starts subnet 1 starts with 0. Okay, so this means each VPC has 256 subnets, and each subnet has 256 IP addresses, which results in 65,536 hosts. So this is the logic of CIDR block, and how you specify your VPC range and how you specify your subnet range. I hope this was useful for you. Thank you.